All right, we're looking at binomial experiments in this video. A binomial experiment is a way to figure out some probability for a certain situation. But this certain situation, it's binomial, which bi means two, and you have like two alternatives. Like if you have a coin, you flip a coin, you have two alternatives, either heads or it's tails. This is a head. It could be making a free throw versus missing the free throw. You either make it or you miss it. It could be something where you get to a road and you have to go to the right or you have to go to the left. You have two alternatives. So that's what we're looking at as far as what a binomial experiment is. You have two alternatives. It's either yes or no, or this or that. What we're first going to look at is like I got a die here, and I roll this die. Okay. Now suppose that my question here is, I'm going to roll this die. I'm just going to go real. I'm going to have 3 rolls on this die. Okay. Now, in these 3 rolls, what's the probability that I have 2 5s? What's the probability that I roll a 5 twice? Okay. So, if I roll it here, let's do it 3 times here. There's 1. I got a 3. There's 2. Got a 5. All right, there you go. Now, did I get a 5 again? Oh, I got it. What's the chances? I got 2 5s. That's awesome. Now, can I do it again? Let's see here. Well, there's a 4. Oh, that wasn't a roll. I just dropped it. A 2. I didn't do it. And I got 1 5. But now, what's the chances I do that again? Well, if I'm rolling this die 3 times, the chances I get 2 5s, that's not going to be very high probability. What would the probability be? Well, this is a binomial experiment. And how we calculate that probability would be like this. It's going to be, well, first of all, let's look at combinations. Okay. You have these 3 rolls. What's the probability that 2 of these are a 5? Okay, well, I think here's my alternatives. I could have a 5 and a 5 and something. I could have a 5 and then a something and then a 5. Or I could have the something and then a 5 and then a 5. There's 3 ways that this could happen as far as my combinations. Now you can type this on the calculator. So this is what we've looked at in our class using this calculator here. And I'm going to show you can do this with other calculators. But what I have here is, this is a combination of 3 rows, and I desire 2 of them to be a 5. So this is a combination of 3 choosing 2. Okay, so I would do it like this. 3, math, if you remember doing this, it's NCR, and then 2. I don't know if you can see that very good on the calculator because of the light here. 3 NCR2, and I punch that in. There's 3 alternatives. And see, here they are. There's 1, 2, 3. 3 alternatives. Now, what if it was 4? What if I rolled 4 times and I wanted 2 of them to be a 5? Okay, well, there's a few more possibilities. Let me just go up here and I'll change this to 4. 4 NCR2. All right, there's 6 alternatives there. Now, how would that be? Whoops, see, I have 1, 2, 3, 4 rows, and I desire 2 of those to be 5. Well, the first 2 could be 5, and then these here, I don't know. I'm just going to put X's, because it's easier to draw X. This could be a 5, X, a 5, and an X. There's 2 5s. This could be a 5, X, and an X, and then that could be a 5. Okay. This could be an X, that could be a 5, this could be an X, that could be a 5. x 5, 5x, or x, 5, 5. 1, 2, 3, 4, 5, 6. See, there's 6 ways to do this. All right, so first of all, you have to think about combinations. Now, you could use a calculator like we've done in class to do combinations. Now, you also could do a calculator with like this right here. This is just a $10 calculator you can get at Walmart, whatever. But if you notice right there, there's the NCR right there. So if I was to do 4 NCR2 here, I just go 4, hit that NCR, and then 2, and then bam, there it is, 6. Okay. Well, now you could also do it on your phone. Let me get my phone here. Okay, here's your phone, and my calculator options right there. Okay, all right, now let me turn it sideways, and here you go. And if you notice, this is it's got the x factorial on here. That doesn't have an NCR, but here's what you got now with NCR. If I do combination of 4 things choosing 2, which is what we're doing right here, that should be 6. Okay, now what this is going to be 4 factorial divided by 2 factorial, and I do 4 minus 2, which is also 2 factorial. So I got to do 4 factorial divided by 2 factorial and divided by another 2 factorial. So let me, wrong calculator. So let me show you how you do that on your phone. All right, so I'm going to do 4 factorial, which is 24, divided by 2 factorial, which is 12, divide again by 2 factorial, which is 6. So that's how you could punch it in on your phone if you don't have a calculator. Let me do one that these numbers are different so you can understand on this. Okay, let me first go to this calculator. I'm going to do 5. If I do this 5 times and get 2, okay? Well, look here. If I just punch it in on the calculator here, 5 choose 2, that should be 10. Okay, now I'm not going to draw them out to show you what they are, but this is 10. 5 choosing 2. Well, that's going to be 5 factorial divided by 2 factorial and 5 minus 2, which is 3 factorial. Okay? So that's what I would be typing in. So if I have to do this on the phone, like if I don't have a calculator, I can do it on my phone. All right? Which is going to be 5 factorial, 120, divided by 2 factorial, which is 60, and then divide again by 3 factorial, which is 10. So you can see that you could do it on your phone. You get 10 either way. 10 either way. Now it's much easier just if you have a calculator like this, you can just do 5C2 and bam, there it is, 10. But if you don't, you could always use your phone to calculate what the combinations are. All right. Well, back to this binomial. Let's rewrite this out. I'm going to do 3 rows. All right, what's the probability that I get 2 5s in these 3 rows? What's that probability? Well, the combinations is part of it. So it's going to be a combination of these 3 rows selecting 2. Okay? Because, like I said, it could be 5 and 5 and then an X. It could be 5 and then an X and then a 5. Or it could be an X and a 5 and a 5. There's 3 ways you could get this. All right. Now that's not your probability though. That just tells you the order that they could come in. Now here's where your probability comes in. You got to times this. And so to get a 5, when I roll this die, okay, there's 6 sides on this. So to get a 5, the probability would be 1 out of 6 to get a 5. All right, well, I want 2 5s. So I've got to square this. Okay? But now that third row, the third row does not need to be 5 because I just want 2. I don't want 3. So that means that third row, the probability is 5/6 because I don't want a 5 for that third row. And so that would be to the 1 power. And this is how you calculate your probability. So this right here we already did, which we said this was 3. So you could just type this on your phone or on the calculator. We said this was 3 times 1/6 to the 2nd power times 5/6 to the 1 power. And then you would just punch this in. So let me do it on this calculator. And actually, you could just type on this calculator, you can just type it all in like this. So let me just do that. 3 NCR2 times, in parentheses, I'm going to do 1/6 to the 2nd power times, and then I'm going to have 5/6. Let me get there, 5/6. I got to put in parentheses. 5 divided by 6. And then that's just to the 1 power. And I don't even have to put that actually. And there you go. And you can see this is 0.0694, the 4 repeats. This is what my probability is. It's a 6% chance. And I did it the first time. How about that? And so, here, I can simplify it by just taking 3 dice and just doing it all at one time. So there you go. Didn't get a 5 at all. There's 1 time. There's a 5 there. That's twice. There's 3 times. 4 times. 5 times. 6 times. 7 times. I mean, I can just do this over and over and over, and getting the 2 5s it's not going to happen very often. But I did it the first time. That's crazy. But anyway, this is what my probability would be. Okay. Now, if you do it on your phone, if you was to calculate this on your phone, well, you would punch this in like I just showed you how to do. That would be 3. And then you'd have to punch these in separately. So like right here, you would do 1 divided by 6, which is this. And then you would square that. Okay, my square button. Well, I can just hit this right here and then do 2. And I would get that. And see, the problem with doing this now on your phone is you got these repeats on here. So this is going to be 0.02 and the 7's repeat. Now you see here at the end it's got that 8, which it just rounded it because that's all the room it has. So it rounded it to. All right, so then if I do this one, okay, 5 divided by 6 is this, and so if that's just to the 1 power, so it's going to be a 0.83 and the 3 repeats. So this one I'm going to type in. All right, so if I type that in now, I'm just going to go ahead and leave this on there, and I'm going to times it by 0.02, and then just hit a bunch of 7s. Okay. And then times 3. And it comes out to this right here, 0.0694. It repeats, and you can see I got the same thing. Okay, now it's a little harder on your phone, but you can do it. The ideal thing is if you had a calculator like one of these, and like I said, this is just a $10 calculator, and you might have a couple of them at your house. I don't know. Anyway, now let's look at some of the problems that's on our assignment we're going to do. Okay, and let's just look at this first one here. A coin is tossed 15 times. What's the probability of obtaining exactly 1 head? All right, so that means we want 1 head and we want 14 tails. Okay. Now, what's the chances of doing that? Well, I would say that's very slim. So if I was guessing, I would say it'd be something like this right here. Or I don't know. Maybe it's a 1% chance. I don't know. But we're going to calculate it up. All right, so how would I do this? Well, a coin is tossed 15 times. We want one head. So that's going to be a combination of 15 tosses, and we desire one toss to be a head. Okay? Times. All right. Then, of these 15 tosses, we want one head, and the probability of getting a head is 1/2. So that means it's going to be 1/2 to the 1 power, because I only want one of those. And then to get a tails, well, that's also 1/2. And that's going to be to the 14 power, because we want 14 of those. Okay, so I'm just going to type it all in at one time on this calculator here. Okay, so it's going to be 15C1 times, and then parentheses 1/2 to the 1 power. No, so I'm not even worried about that. Times, and then I got 1/2 in parentheses. I didn't put in parentheses over here. Me. All right, go back. 1/2, and then to the 14th power. So I'm just going to go to the 14th power there, and there you go, man. This is all right. Look here. It says point. It's 4.5776 to the -4, which means it's going to go 1, 2, 3, 4 this way, which means I got to put these zeros in. And so I think it is this one. See there, 0.000. The 5 makes the 4 go up to a 5. So that was the answer right there. Okay. Here's another one here. I'll let you do that one. Okay. All right. Let's go to this one. A single die, this number 4, a single die is tossed 5 times. What's the probability of obtaining a 4 3 times? What's the probability of obtaining a 4? All right, so this is going to be a combination. We're going to do this 5 times, and we desire 4 times to be a 4. I'm sorry. Get my numbers mixed up. Obtaining a 4 3 times, so this would be a 3. We're rolling a 4, so we're tossing this die. We want it to be a 4. Okay. So we actually have 5 of these dice. Okay, and we want a 4. We want 3 4s is what we want. Okay, so we're doing this 5 times, and 3 times we want a 4. Okay, of the 5 times we want 3 of them to be 4. Now, what's the probability of getting a 4? Well, that's a 1/6. Okay, and I want 3 of those. That's to the 3rd power. But the other 2 times, I don't want a 5. So that's going to be 5/6. And that's the other 2 times. And so I would just times these up. Okay, so if I do this on my little calculator here, all right, 5C3 times, in parentheses, 1/6 to the 3rd power, so to the 3rd power, and then times, and then 5/6 to the 2nd power. And there you go. Right there it is, man. So 0.03215. Okay. I don't care if you round it to 3 places or 4 places or whatever you want to do. Some of these you might have to go 4 places, like this one up here, because, you know, 0, 0, 0, 4, it had all these zeros in front. So okay, now look at number 6. Number 6 here. A single die is tossed 8 times. What's the probability of obtaining a 4 5 or more times? All right, 5 or more. All right, that means of these 8 times you're rolling it, you want a 4 5 times, 6 times, 7 times, or 8 times. So there's 4 different ones here. So what you're going to have to do is just like we did here in 4, I'm going to have to do each one of these, and then I'll add them all together. Okay, so if I do 5, that means it's going to be a combination of I'm doing this 8 times, and I desire 5 of them to be a 4. Times, and then on that single die to get a 4, that's a 1/6, and I want that 5 times, which means 5/6 the other 3 times. So there's what I would have for the 5. Okay, so I would just punch it into my calculator, and I'll do that here in a second. Okay, then I'm going to have, of the 8 times, 6, because it's got to be 5 or more. So what if about 6 of them? So that's going to be the 8 choosing 6 times, you got a 1/6 probability to the 6th power, because I'm going to do it 6 times on this case, and then of the other 2 times, I don't want a 4. Okay, then there's a possibility of getting 7 of them. All right, so that means I'm going to have, of the 8 times, 7 of them being a 4, which means it's going to be times 1/6 to the 7th power, and then 5/6 to the 1 power. Or then 8. I desire all 8 of them to be a 4. Now, that's not going to happen very often at all, is it? So that means to the 1/6 power, all 8 of them, and then 5/6, I don't have to worry about those because I'm not going to have something that's not a 4. So I would do each one of these and add them all together. All right, so let's start off. I may not have left enough room in here between these, but we'll squeeze it in, I guess. All right, so as I do this one here, so it's going to be 8 choosing 5 times, and then I got 1/6 to the 5th power times 5/6 to the 3rd power. And that's going to be, oh yeah, look at there. See how this is to the -3? That moves over 3 places. Can y'all see that good there? See, this is scientific notation now. This -3, my decimal moves back this way 3 places. So it's going to be, oh yeah, I didn't leave enough room. 0.004167 Okay, see my answer there? So I move this 3 places. So moving it 1, we put on this side of the 4, and I have to put 2 zeros in front of the 4. So 0.004167 Okay. All right. Now, if I do it 6 times, it's going to be even less than that. So now, what you can do if you have on this calculator, man, this is going to be a breeze, because all I'm going to do is I'm just going to go change this right here to 6. I'm going to change this to 6. And I'm going to change this to a 2. Okay, so these calculators are just a breeze. And there you go. See my exponent here, -4, which means I need to move this back 4 places, which means this will move it 1, and I'll have to have 3 zeros. So this is going to be 0.00041676. Okay, so there's that answer. All right, there's 2 of them. Now I got to do this one. All right, so now, like I said, I'm just going to go change this. So obviously, it's a lot easier if you have this calculator. And there you go. This is -5 exponent now, which means I got to move this back 5 places. So here's my decimal. So if I move that 1, that means I have to have 4 zeros in front. So 0.0000, and then 238, 149. There you go. There you go. And then this one here. Okay, let's go back in here. We'll just change this to 8. And this is going to be an 8. And I need to get rid of that. I'll just make this a 0 here because it's not a. There you go. Oh, look at this, 7. So this goes back 7. So there's one place right there, which means I have 6 zeros. So it's going to be point 1, 2, 3, 4, 5, 6 zeros. Then I have the 5 and the 9, 5, 3, 7, whatever. Okay, and then I would add all these up. Okay. So if I add those, all right, I've already got this one on the calculator. So plus, okay, do this one here. So point 1, 2, 3, 4 zeros, 2, 3, 8, 1, 4, 9, plus this one. So point 0, 0, 0, 4, 1, 6, 7, 6, plus, and then this one, point 0, 0, 4, 1, 6, 7, 6, and there you go. There's my answer right there. Okay, so this comes out to be, now see this to the third, so that means I got to move this back 3 places, so that moves it 1, and I have to have 2 zeros. So here's my answer right here, point 0, 0, 4, 6, 0, 8. I'll just leave it like that. That'd be it right there. So if I roll a single dice 8 times, what's the probability I get a 4, 5, or more times? Well, I mean, it's less than 1%. See, if I change this to a percent, that would move, it's 0.46%. It's less than 1%. So, yeah, that makes sense. So if I have, let's see, have we got 8 of these? Yeah, we've got 8 of these. Okay. There's 8 of them. So if I roll this, and if I do this now, this is going to be crazy. What's the chance I get a 4, 5 or more times? So of these 8, 5 of them being a 4 or 5 or more of them? Let's see. Oh, no, I had 1. Do it again. Well, had 2 this time. But it's not going to happen very often. It's going to happen less than 1%. So that's what you're looking at here. Now, let's go down to this. A student fails to study for a 10-question true-false test. Number 8 here. What's the probability that the student gets exactly 6 questions right? Now, there's 10 questions. You want 6 right, and it's true false, which means that's a 1/2 probability to get it right. All right, so that means it's a combination of these 10 questions, getting 6 of them right, times, and then the 6 right ones, you got a 1/2 probability of getting it right, and you're going to have 6 of them right. But then you're going to have 4 of them wrong, so that's a 1/2 probability that you get one wrong, and that's to the 4th power. All right, so you can calculate what kind of your probability of getting would be a 60, wouldn't it? 6 out of 10. But it's going to be 10, choose 6 times, and then I got a 1/2, 1 divided by 2 to the 6th power, and then times, and I got 1 divided by 2 to the 4th power. Okay. And there you go. It's a 20% chance. How about that? 0.20507. That's my answer there. Okay. Let's go down here, number 10. Number 10, a student fails to study for a 9-question multiple choice test with 4 answers for each question. So you have A, B, C, or D. You got 4 choices. What's the probability that the student gets exactly 6 right? All right, so this is going to be a combination. There's 9 questions, and you desire 6 of them to be right. All right, you times that by your probability of getting it right. Well, there's 4 possibilities, so that means you got a 1/4 chance to get it right, and you want 6 of them. I got this line here I shouldn't have had. So just ignore this line. And I'm going to times that by the other 4 I'm getting wrong, which is a 3/4 probability that I get it wrong. And I've got, I'm sorry, 3 of those, not 10. There's 9 of them. So of the 6 right ones, that's a 1/4 to get it right. So that's 6 of those. But there's 3 going to get wrong. So it's 3/4 to the 3rd power. Now what does this come out to? All right, let's see here. 9 choosing 6 times 1/4 to the 6th power. Oops. And then times 3/4 to the 3rd power. And there you go. Now look here now. I got this scientific notation, -3, which means this moves back 3 places. So it's going to be 0 point, and I move 1. Means I have to have 2 zeros in front of that 8. So it's going to be 8, 6, 5, 1, 7. There you go. That'd be my answer. I didn't circle it very good. Okay. Now flip this thing over. Oops, no, that's not. Here we go. Here's one similar. Student fails to study for a 12-question multiple choice test with 4 answers to each question. What is the probability that the student gets 8 or more? So this is going to be like the one we did a while ago. That means we're going to get 8, 9, 10, 11, or 12. So you're going to have to do 5 different ones here and then add them all together. So I'm going to leave that one up to you, okay? Oh, I'm sorry. I'm writing on here and it's not on the screen. Sorry about that. Student fails to study for 12-question multiple choice test with 4 answers to each question. What's the probability that the student gets 8 or more right? So it's going to be 8, 9, 10, 11, or 12. So you're going to have to do one for 8, you got to do one for 9, you got to do one for 10, one for 11, one for 12, and you add them all together. Okay. And then here, it's a 15-question multiple choice test with 4 answers to each question. What's the probability that the student gets 10 or more right? So it's going to be 10, 11, 12, 13, 14, 15. So you're going to, there's 6 of them. You're going to do all 6 of them and then add them together. Okay. Now, if you need help with that, let me know and I'll help you with it further. But I'm going to leave that up to you. I think you guys can do it. And then we have this down here, this last part. And see, these binomial experiments, therefore, find the probability of certain situations. You could use these experiments to figure out probabilities of certain things. Like right here, a family has 5 children. What type of simulation should be used to predict the number of boys and girls in the family? All right, so you got 5 children. What could you possibly have? Well, you could have 2 boys and 3 girls. But even in doing that, if you have 2 boys, 3 girls, it could be like this right here. The oldest ones are boys and the youngest ones are girls. Or you could have this. Okay? Or you could have this. The oldest one's a boy and the youngest one's a boy. And there's different probabilities. So this is where your combinations come into play. And then you have your probabilities. Anyway, this is a binomial experience. It's either a boy or a girl because you have two possibilities. But now which one of these would model that the best? And I think this would be B, flipping 5 coins. So here you go. So here's 5 coins. If I flip these coins, all right, look here. Let's say the head's a boy. So look here, this is 2 boys and 3 girls. All right, so that's what we had here in our little case. So let's do it again. Okay. Oh, that guy went way over here. And look here, we got, all right, look here, 1 boy and 4 girls. Okay, so this would model the experiment doing this 5 coins. And these other ones are similar type things. You guys try to figure them out. But these are just ways to model certain situations. But anyway, that's what we have right here with these binomial experiments. And if you have any other questions, let me know, okay? I'm here for you. I'll help you anytime. So have a great day.